So far, we've seen some basic examples of the list data type. We know that they are denoted with square brackets and that they contain a sequence of values separated by commas. We learned that you can iterate over a list, and the loop index variables assign the next item in the list for each iteration of the loop. We also know that many of the operations we perform on strings, such as indexing, slicing, concatenation, and repetition, also work on the list data type. We have created a list of strings using the string split method, and used the strings join method that takes a list of strings as a parameter. We'll use the debugger to step through this program that shows some of the list concepts. We also know that lists are mutable, so you can change the elements of a list. In this example, we'll change the value at index 2 to the value 4. The range function gives us a sequence that we can iterate over, but for efficiency reasons doesn't produce an actual list. If you want a list from the range function, you have to use the type conversion syntax we've learned for converting between strings and ints. You put the name of the data type, followed by parentheses. Inside the parentheses, you put the value you want to convert to a list. We can see that items is now the list of the 5 integers 0 through 4. Only expressions you can iterate over can be converted to a list using this syntax. We can't convert an int to a list since you can't write something such as 4x in 3 : If you want to make a list containing a single value, you use the square bracket notation as we did here. If you convert a string to a list, you get a list in which each item is a single character from the string. This makes sense since as you iterate over a string, you get one character from the string each time through the loop. A later chapter in the book covers more details of lists, but for now we'll learn one list method. The append method allows you to add the result of an expression onto the end of a list. It does not make a new list. Instead, it modifies the existing list to add one more value to it. In this example, we've appended the value 5 onto the list that was 0 through 4. The result is items is now the list 0 through 5. We could accomplish the same task using the concatenation operator with 2 lists, but in this case we need to make a list out of the integer value 6. If we use the plus operator with a list as the first operand, the second operand also must be a list. This version is less efficient as it creates a list for the 6 and then also creates a new list with all the values 0 through 6. The append method uses the same list and just adds a new element to it. Since it doesn't need to create a brand new list, it is more efficient. Let's say we want to make a string with all the lowercase letters in the alphabet, but we don't want to write it out directly as we might make a typo that is difficult to notice. We can use the accumulator pattern to build up the string. For strings, we initialize the accumulator variable to the empty string. Next, we iterate over the Unicode value for each of the lowercase letters. Note that we add 1 to the Unicode value of z, otherwise it will stop at the Unicode value for y, since range stops 1 before the specified value. We can now use string concatenation and the chr function to add the next letter. When the loop completes, s is the string of lowercase letters. We know making a new string each time is inefficient, so we'll rewrite this and use a list to accumulate the letters. For a list, we initialize the accumulator variable to an empty list and use append to add one element to the list each time through the loop. Appending a value onto an empty list modifies the list so it contains that one value. That is why we initialize the accumulator variable to an empty list for the accumulator pattern. In this version, we append each letter onto the end of the list. When the loop ends, we have a list of all the letters. We call the join method using an empty string as the separator character and pass it the list of letters to join together. The result is the same string of lowercase letters, but this version is more efficient. Because modifying the elements of one list to create a new list is a common operation, Python has a special syntax for this known as a list comprehension. You use the square brackets and put the operation you want to do on the loop variable first, and then write the loop. The way to read this is we are performing the chr function on each value I from the ord of a through the ord of z. We get the same result of a string of lowercase letters. We can also write this all in one line without creating a name for the list. We take the list we create and immediately pass it as the parameter to the join method. This also produces the same results. We can now rewrite our Unicode decoder program in a more efficient way. Instead of using string concatenation as we did before, we will accumulate the letters as the elements of a list and then join them together. Just as we did before, we split the string of numbers so we have a list of strings. We then iterate over the list, convert each string to a number, and convert each number to its Unicode character and accumulate the characters in a list. I'll debug it and paste in the Unicode values for a message. We'll step through the loop a few times and see that each numeric string is converted to the corresponding number, and then we convert it to the character using the CHR function and append it to the list. We'll resume and see that we now have a list of all the characters. We can use the strings join method with an empty string to join the list together. Remember that both split and join are string methods, so you need a string before the period when you call either one of them. The result is the message corresponding to those Unicode values. We could also do this using the list comprehension syntax we've learned. For each numeric string, we convert it to its corresponding number, and then use the CHR function to convert that number to a character and make a list out of all those characters. As you should expect, we get the same result from this version. The list comprehension syntax is concise, but until you are more comfortable with that syntax, the version that uses the append method may be easier for you to understand and follow. For now, feel free to use the syntax with which you are more comfortable.